In this video, we are talking about a problem that was given in IIT 2015 from laws of motion basing on connected bodies. The problem is like this. Three bodies of masses A, B, C, 4, 2 and 1 kilogram. So, now you mean to say this is 4 kilogram, this is 2 kilogram, this is 1 kilogram are in contact with a frictionless surface. This one is a frictionless surface, you mean to say. If a force of 14 Newton here is applied on the 4 kilogram block, then the contact force between A and B is how much? It's purely basing on connected bodies. We can draw free body diagrams for each of them. I will take a fresh diagram and show all those things to you, right? Let me consider a frictionless surface here. On that first, there is a 4 kilogram block. With that connected is a 2 kilogram block. With that connected is another 1 kilogram block. Here a force of 14 Newton is applied as it is given. Then one thing is obvious is as you have applied force from left to right, the entire system is supposed to move from left to right. What happens is this 14 Newton acts on 4 kilogram and it pushed the 2 kilogram block with a force. Let me call that as contact force C1. That's an action. 2 kilogram force then will apply a reaction of the same magnitude but on the opposite direction. So if you try to draw a free body diagram for 4 kilogram body, what are the forces acting on that 4 kilogram? When you are drawing a free body diagram, be aware that we always consider the forces acting on the body. We never consider the forces applied by the body. So 14 Newton is acting on this 4 kilogram. Now we have, if you see carefully, there is C1 applied by 4 kilogram on 2 kilogram in the upward direction towards the right. I am talking about this. There is another force applied by 2 kilogram on 4 kilogram. See, be careful. This is applied by 4 kilogram on 2 kilogram. So it is acting on 2 kilogram. We shall consider that only when you are studying the motion of 2 kilogram. Look at this bottom one. This C1, that's a reaction is applied by 2 kilogram acting on 4 kilogram. Now when you are drawing a free body diagram, we shall consider the forces acting on the body, never the forces applied by the body. So this C1 has to be counted. This shall not be counted while we are studying 4 kilogram. So entire motion is towards the right. So what we can say is F resultant on that 4 kilogram is 14 minus C1 because it is moving towards the right. Force in the direction shall be treated like positive. Force against the motion shall be treated like negative. So 4A, because it's acting on 4 kilogram, A is an acceleration of the system, is 14 minus C1 is the first equation. Now look at this 2 kilogram. This 2 kilogram, now let us consider this 2 kilogram. When 4 kilogram pushes 2 kilogram, 2 kilogram pushes 1 kilogram forward with a contact force C2. That's an action. Be careful, the C2 is applied by 2 kilogram on 1 kilogram. That's an action. Then this 1 kilogram is going to apply a reaction on 2 kilogram by the same value of C2. So what is this C2? By 1 kilogram on 2 kilogram. Now let us try to draw a free body diagram for this 2 kilogram, right? Let's try to draw for this 2 kilogram. What are the forces acting on the 2 kilogram? This 14 Newton is not acting on 2 kilogram, it is acting only on 4 kilogram. But when 14 Newton acts, 4 kilogram pushed 2 kilogram forward with a C1 like I have shown earlier. This is acting on 2 kilogram towards the right. This is C1. Now, I won't be counting this because this is applied by 2 kilogram but acting on 1 kilogram. We are writing the forces acting on 2 kilogram. So we can count this because this is applied by 1 kilogram but it's acting on 2 kilogram, C2. And the motion of the system is forward. Then again I can write F resultant for that. F resultant is 2A C1 minus C2. Why C1 first positive is it's along the motion. C1 is negative because it is against the motion. That's for the second body. Similarly, you can draw for the third body, free body diagram, 1 kilogram. On that, this 2 kilogram applied as C2 by 2 kilogram on 1 kilogram, C2. There is no other forces acting on that because there is no further body. So the motion is also in a forward direction. So 1A equal to C2. Thus I got C2 value. Substitute the C2 value here in this equation. That implies 2A is C1 minus A. So 3A equal to C1. Put that C1 or here. This value of the C1 here in this equation. 4A becomes 14 minus C1 means 3A. Get this 3A this side. 7A equal to 14. So A equal to 2 meter per second square. You got an acceleration of the system. But he is not asking acceleration, the contact force between A and B. Between A and B, the contact force is C1. That implies what is C1 is his question, right? So you can say to get that C1, you can use any of this equation. You can use this equation, say for example, from equation number 1, 4A equal to 14 minus C1. 4 into you have found that A as 2 is 14 minus C1. So C1 equal to 14 minus 2 into 4 is 8. So that's nothing but equal to 6 Newton. So the contact force between A and B is 6 Newton. Of course, we can find out all the other contact forces too also. We can find out C2 as 1A as we have proved. A we have proved it as 2. So C2 equal to 2 Newton. We can find both C1, C2 and acceleration of the system using free body diagrams. So the most important part of all this discussion is how do you draw free body diagram? How do we draw free body diagram is there are two rules. Rule number 1, write forces only acting on the body, never the forces applied by the body. Number 2, identify the forces along motion shall be treated as positive and vice versa. If you take that two things into consideration and study the problem, you can in fact able to write all kind of free body diagrams itself. That's how we solve this problem. Thank you for watching.